Good morning, everyone, or I guess good afternoon if you're in 7th period. I'm going to attempt to talk through a video. I realize you don't have the handout, so you'll have to get out some scratch paper. And we're going to talk about square roots, and I don't think we're going to get to rational exponents or polynomials in this video, but eventually we will. So I've missed you guys. It's been a long week. I'm back among the living now, but still have a bad cough and don't feel great, but earlier in the week that was rough. But relax in terms of your college algebra grade. I'm not going to throw any kind of quiz or test at you while I'm gone. We'll take things slow. So, all right. I think you're probably pretty familiar with square roots. For example, up at the top, I don't think you have to write that down. Square root of 100 equals 10. And you're welcome to always use a calculator. That check mark thing is called the radical, and the number under the radical is called the radicand. So just some terminology there if you're interested. A problem that we encounter is that second example right here. Because if I type that in, I get, let me type that in real quick, 22.36, and it goes on and on. So way different from that one. It's an irrational number. So we need to simplify the radical in order to finish that problem out. So I give you a hint right there. Are there any factors of 500 that are perfect squares other than 1? So one that's really easy to work with, I typed the one above it as a hint, is 100. So what if I break 500 down to 100 times 5, then you don't have to write every one of these steps. Then 105 can separate, and then you know exactly what to do. 10. The square root of 5, you just leave it alone. And that is simplified form. Square root of 500. So that's what we're going to be doing today, is we're looking for perfect squares inside of these numbers. Now, you might always want to check to see if the number itself is a perfect square, like square root of 100, because then you end up breaking it down and you just wasted time. All right, so let's tackle example 1, parts A through D. I'm trying to do this without having a coughing attack. Square root of 50, you type it in and you get 7 point something. So we want perfect squares. And on all of these, you might pause the video, and you can hear my dog in the background. He's sleeping and maybe having a bad dream. I don't know. He's whimpering. Maybe someone stole a treat from him. I don't know. But anyways, I would break A down to that. And then just like I did up above, I would take the 25 out. And I would be left with that. On 1B, if you type that into the calculator, you get a whole number. So no work to be done on that one. On C, very similar to square root of 500, let's use 100. Take the 100 out and leave the square root of 2. All right. hopefully you're trying these before I do them, so maybe hit pause before this one. I would break this. Now, there's a bunch of ways to do this. I'll show you 2 ways. I could see some people picking this way, or I could see some people picking this way. We'll both end up at the same spot. If you picked the right way, 4 and 5, you're going to go a little faster. The problem with 10 and 2 is neither of those are perfect squares. So you have to keep breaking it down. When you get to there, you see, oh, there's 2 2s. That means there's a 4 in there. A 4 can come out, and it gives us this. Or if you saw the 4 in the first place, that 4 comes out, and we have a 5. Both ways get you there. One way a touch faster. All right, now we got to deal with x's. So let's give that a try. Same concept. We're looking for pairs. So you saw it a second ago on that square root of 20. Let me rewrite that or pull it back up. We had a pair of numbers right here. Well, that's a 4. It's also a pair. So on example 2, whenever we get a pair of letters, that can come out. If you have more than a pair, then sometimes some of the letters get left inside, kind of like some of the numbers getting left inside. But pairs can come out, and they simplify down to just one number. So if I take a pair of 2's out, it became a 1. Or you can read that as a 4. Square root of 4 is 2. So same idea. If I have x squared, or if I have x times x, that just automatically turns into x. Square root of x squared is x, or read it as there's a pair of x's, so an x comes out. All right, that's what we're doing here. So, 2a here. Sometimes it helps people to just put one radical. Shuffle the letters and numbers around so that you get them next to like things, and then you see it better. 6 and 3, there's not really much going on there, so I'm going to break that 6 down further to see if there's something else. All right, now we have something going on. We have a pair of x's here, and we have a pair of 3's here. So we're going to have a 2 left inside. But that pair of 3's comes out. Really, that's like a 9. So square root of 9 is 3. And square root of x squared is x. All right, I hope that made sense. Maybe give B a try. Hit pause before I do it. All right, I'm going to pick up the pace a little. Hopefully it's clicking. We have a 5, a 2, and we have 3 x's in here. Let's write it like 3 x's. I mean, the way I had it wasn't wrong. All right, not much can happen here. I can't break the 5 down. I have a pair of x's, so that comes out. But the 5 and the 2 are stuck. So I have a 10. And then only a pair of x's came out. There's still an x in there. So that's my answer on B. C, believe it or not, is very easy. That turns into square root of 49 over square root of 4, which is just 7/2. All right, new rule. Well, maybe new rule, I don't know. Let's add it to our notes. To simplify a square root radicals cannot be left in the denominator. So on part D, when I separate that into two square roots, I have a square root of 12. Now there's a few different ways to approach D. You could reduce that fraction from the start, and I think that would actually make it easier because you'll be working with smaller numbers. So let's actually do that before we do anything else. Ignore the square root for a second. Reduce 32/12. So let's see, both are divisible by 4, so we got 8/3. Now let's deal with the radical. So I'm going to chop that into 2 radicals. And there's a trick to dealing with that radical in the denominator. If you multiply by whatever is down there, it's going to make the radical disappear. So we end up with that up top, and square root of 3 times square root of 3 is square root of 9, which is just 3. All right, we have a tiny bit more work to do in the top. Break that 8 down. We got a 4 in there. So final answer, this is a long one. Is that. If you're confused where the 6 came from, I had 8 times 3, right? So I had to break the 8 down, broke that down to 4 and 2. The 4 came out, the 2 and the 3 were left inside, so you got to multiply them back up, and it's a 6. Hopefully that made sense. All right, I'm going to scroll down a little. We're almost done. Although that last one, G, is not any fun. E and F are not bad. So E, at first glance, looks like I can't really do anything, but I can break that 12 down. So I know I can break it down to like a 4 and a 3. So the 4 comes out. And now we have 2 like terms. That is identical concept to this. I know you guys can all do that. That's 9x, right? Same exact idea. It's kind of like, in reality, we don't know what square root of 3 is. We know it's 1 point something, but we don't know what that something precisely is. So it's kind of like an unknown. So when we combine those, we write it like that. That's a 9, by the way. I hope that looks like a 9. All right. F is very similar to D. I need to get rid of that 6, so I'm going to multiply top and bottom by square root of 6. And this one goes a little better than D did. Two things to ask yourself. Can 6 be broken down, and does it have a perfect square in it? And then also, can I reduce the fraction? So 6, I can break down to 3 and 2, but there's no pairs. So there's nothing to be done there. It's just stuck at 6. But 15/6, they're both divisible by 3, so I can take that down to that. All right, last one. This one's hard. You need some space for this one. We have a radical in the denominator, but we have other things in the denominator. So there's this trick. If I multiply by its conjugate, 5 minus square root of 3. You should have gone over this concept in Algebra 2. If you didn't, there's this trick, and it has to deal with factoring the difference of two squares. Because when you FOIL out that denominator, so if I put parentheses around this, it's going to cancel out the inner and the outer factors, and I'll be left with just the first and the last. So take a moment and look at what I did. All I did was I took the denominator, multiplied by it, and I changed that middle sign. So if that middle sign had been a negative, I would have flipped it to a positive. So now I just distribute. So up top, we have 35 minus 7 square root of 3. On the bottom, we have a lot, but a lot cancels out. We have 25. We have that, depending on the order you go in. We have that. And then careful with your signs. Square root of 3 times negative square root of 3. I'm going to write it like that. All right. You may be asking, why in the world did we do that? The way it was typed looked a lot better. We'll hold that thought. We got 35 minus 7 square root of 3. Look at those two middle terms. They cancel out. And then if I have square root of 3 times square root of 3, isn't that a square root of 9? This cleans up pretty decently. Square root of 9. I was worried I said that wrong. So yeah, that turns into square root of 9, which is a 3. Final answer. This video turned a lot longer than I thought it would be. Oh well, hopefully that was helpful. I will hopefully see y'all one day, definitely next week. I don't know if I'll be there on Friday, but see y'all later.